Login accepted.
Cool. Cool. Okay, so now the meetings are being recorded. So, who am I? I mean, I kind of already went over this on week one-ish. Yeah, one. I'm the captain for CPTC. I'm also the threat hunter for CCDC. There isn't much else to say. So, where exactly are we? Well, this week we are talking about hacking Linux. Next, you'll be talking about Windows, and then finally consulting before the tryouts. So, let's get started. So, here's the agenda for today. We'll be talking about common services you might find on Linux, stuff like FTP, SSH. Other stuff we won't cover is like DNS, but whatever. Next, we'll be talking about some tools, whether those tools are for reconnaissance, actually attacking the systems, or just general information gathering. Next, we'll take the information from both part 2 and 1 to actually attack those common services using the tools that we've provided you, or we've told you about. And finally, you'll be doing your own lab. First, common Linux services. So here's a quick rundown of the services we'll be covering today. FTP, SSH, HTTPS/HTTP, and a bunch of various databases. While there's other things that can be run on Linux that are going to be common, like DNS, these are the ones we'll be talking about and focusing on, since you'll be attacking these ones more often, or at least more often in our environments. So first, FTP. FTP, or File Transfer Protocol, is, well, a protocol that allows you to transfer and send files. If you can connect to it, depending on how the server is set up, you might be able to connect to it anonymously, or it might require credentials on that actual machine, or just an FTP credential, depending on how the thing is set up and what service it's running, but that's not too important. Usually the service itself isn't going to be vulnerable, though there are some exceptions. I can think of a few. There's stuff like VSFTPD 2.3.4 was backdoored, and then there's stuff like ProFTPD 1.3.5 that had a remote code execution exploit. But generally speaking, you're more looking at the files that are in them, especially if the FTP server itself is anonymous. Sometimes someone could host a sensitive file, maybe an onboarding document that has, well, the default credentials that employees are supposed to change, but they might get lazy and not actually change it. Next, SSH. SSH is a very useful and legitimate tool used to remotely manage your Linux servers. You can also use it to transfer files via SAP. And generally speaking, you're going to need some sort of credential to access, or rather, you're going to need credentials to authenticate into the service, whether that be actual credentials of a user or a key pair of the user. And since it's just a remote management tool, it's essentially just a shell. Next, we have HTTP and HTTPS, something you are probably familiar with, especially if you attended last week's, where that was all about web apps. HTTP and HTTPS is just your average web ports. There can be a lot of different web servers, services hosting stuff on that port, whether that be something like Nginx, Apache Tomcat, etc. Usually the protocol itself and the service itself isn't that vulnerable, and you're going to be exploiting the actual third-party applications hosted on it, as you probably noticed from last week. But sometimes, if you're lucky and you have something like LFI, you might be able to read some config files from the said from the directory that it's hosting the files, and you might be able to steal something like database credentials, which may be reused, or you may find more information on said database. And finally, databases. Databases, they just store information usually necessary for other applications. This data can potentially be sensitive. It might contain stuff like password hashes or just other information that your clients may not want leaked, like PII. And there's a bunch of different databases, and the ports all vary. Stuff like MySQL or MariaDB is usually on port 3306, but then there's Postgres, which is like on 5432, Oracle DB, which I don't remember the port exactly, but point being, there's a lot of different types of databases that you could be interacting with. But generally speaking, you're looking at, you want the data that's inside of it. Next, we'll be going over some tools. So first is MSF Venom. And this tool is, well, it comes with like Meterpreter. It's useful to generate payloads that you want to execute on your target. The example I have here, though it's Windows, the same thing applies. You can see on the bottom that I actually have a Linux one as well. I kind of put the Windows one there since the syntax for Windows and Linux shells is slightly different, but oh well. Yeah, as for the difference, for x86 Windows, you don't have to specify that it's /x86. So that payload example right there is actually an x86 shell. Meanwhile, Linux, you actually do have to specify it on that bottom one. If you replaced x64 with x86, that would generate an x86 payload. But yeah, the syntax for it is going to be MSF Venom, and then the payload type, your host, or yeah, the listener host, so your host, the listener port, so the port that you want to call back to, and then the type of output that you want it to be, or the type of file that you want it to output as. At the top, it's an exe, on the bottom, it's an ELF file. Something important to note is the thing that I've pointed out with an arrow. If you have a slash there instead of an underscore, you get what is known as a staged payload. Staged payloads are smaller and they contain a very minimal amount of code, but they require a handler to call back to. Staged payloads don't actually contain the whole payload. They call back to a handling server, which then sends the rest of the payload. Meanwhile, a staged list payload contains the entire payload. Next, something you're probably familiar with if you did last week's as well, just basic file transferring. So if you want to host a file for the server to call back, or if you want to host a file and then you want the victim's machine to actually call back to it, you can use Python to host it and then stuff like curl or wget to pull it down, depending on whatever the machine you're attacking has, since sometimes it has wget only, sometimes it has curl only, sometimes it has both. There's other ways of transferring files, stuff like FTP, SCP. This is just a very quick and easy and a bit of a dirty solution to transferring files, but oh well. Next, something more oriented towards Linux is linpies. This is essentially a giant bash script that runs a bunch of different commands, all meant to enumerate as many things as possible on Linux. So that can be stuff like what processes are running, what network connections it has, binaries it has, users, et cetera, et cetera. And yeah, it's a very useful tool to know, since it automates a lot of the reconnaissance that you'd be doing normally. But sometimes, rather, it isn't always correct. A lot of the times, actually, I'll talk about it a bit later when we get to the attacks. So we'll just move on. You'll see what I mean, though, by saying it's not always the most accurate. Next, we have stuff like GTFO bins. GTFO bins is essentially a online compendium of a bunch of binaries that, if configured improperly, can be abused for stuff like file read, or potentially higher level executions, or rather, being able to execute stuff as a different user usually a higher privilege user, stuff like root. It's a very powerful tool. And usually if you're finding a bunch of binaries, or rather, if we go back to the example of linps outputs the list of binaries on the system, at least in the common directories. And so if you find one that looks odd, you might be able to throw it into GTFO bins, and it might tell you there's a way to abuse its extra permissions or something. Next is pspy. Pspy allows you to monitor processes without needing root permissions. So this is actually a very useful tool, and it does it in a very interesting way. It, as a very oversimplified explanation, it essentially checks the /proc directory, scans all those files to enumerate what processes are running on the machine and who owns that process. This is because the /proc directory is where Linux stores all process information. But yeah, pspy is very useful, especially if you're trying to find, or especially if you want to know if there's something like a scheduled task, or rather a cron job that's constantly running on the machine every so often. If you don't hack the box, you're probably familiar with this tool since it's used quite often. Next is Google. You just need, sorry. If you found some third-party service you're not very familiar with, just Google it. There might be an exploit for it. You might be able to do stuff that's not necessarily an exploit, but maybe it has functions you're not very familiar with. You can Google it to figure out what it does and the like. From, I believe, week 2, we explained a bit about passive recon. The Google dorking tips that we gave for passive recon do apply whenever you're just researching general stuff. So stuff like quotation marks to make sure your search includes that specific query, minus to remove anything specific, etc. And of course, while I didn't mention other tools like Meterpreter, why I didn't mention tools like Meterpreter that I believe we talked about during week 2. Meterpreter is also a useful way to just search for exploits and potentially exploit and pwn that machine and get your initial shell onto the box. Next, we have attacks. So while there are a bunch of different attacks, here are the attacks we'll be covering today. SUIDs and SGIDs, so set user IDs and set group IDs, environment variables, weak file permissions, vulnerable applications, kernel exploits, pseudo abuse, and cron jobs. 1 second. So first, insecure file permissions. So just weak file permissions on sensitive files is obviously a bad thing. Whether those files be your standard native Linux files like etc password, etc shadow, or other things that relate to third-party applications like config files, etc. For stuff like native Linux files like etc password, though it's a very niche case, if you can write to it, you may be able to modify your user's permissions. If you can write to shadow, you might be able to modify, or rather, you would be able to modify a user's password. It's a bit more niche, but if you do get privilege escalation to having arbitrary file write, you could potentially write a hash into the root user. Meanwhile, if you have, sorry about that. If there's improper file permissions on, say, a config file, maybe that config file contains credentials to a database, to a different user. If that's not supposed to be read by your current user, but you might be able to laterally move or even change to a user with higher permissions. Next is SUIDs / SGIDs. So set user IDs and set group IDs are flags that tell the binary to run as the user or group that owns that file. From the bottom, if you were to do an ls, or rather, the bottom image is an explanation of what those permissions are. So if you were to do an ls slash, I think L, so I usually just do ls slash LA or dash LA. It'll show you the permissions of all the files. And if you see an S on the first two, so I guess technically the third and the sixth location starting from the left, that S represents the SUID and the SGID bit respectively. Whenever you execute these binaries, you're executing them with the permissions, or rather, they'll spawn as whoever owns that file. Here's a bit of an example of how you can abuse it, specifically using. Here's an example of how you can abuse it. So on the left, we are searching for a bunch of different files. We want to find a binary that has an SUID bit that is owned by root. So that's exactly what this find command does. It's finding all binaries, or at least all binaries in the bin directory that have one, the SUID bit, and two, that is owned by root. And at the very top, we can see bin bash, something you're not really going to see that often. But if you've modified the file to be an SUID bit, then maybe you'll find this. Anyways, so now that you've seen the bin bash SUID bit, you can throw it into something like GTFO bins to see if it has any information on it. And surprise, it does. And so when you search it up, you see the entry, and that to abuse this, all you have to do is call the binary, or all you have to do is call bash tac p. And so when you do it, at the very bottom right, you can see you get the permissions of the root. You get the permissions of the owner. In that case, it is root. Okay. Next, you have sudo abuse. Sudo, standing for super user do, allows you to run a file or binary under the context of a different user. Usually that is root if nothing else is specified, but it could be a different user if the sudo config is set to be like that. Again, similar to, I guess, in this case, you're hoping that whatever binary you have sudo access to is broken in some sort of way that you can execute stuff that you weren't meant to. And so with this case, with this hack the box forge, you have sudo permissions over a custom Python script called remote manage.py. And it's just pure sudo, so you'll run it as root whenever you execute it. Or rather, whenever you execute it with sudo. So we do that, and then we connect to it on a different terminal, or in this case, a different TMS pane. And we do something that's unintended. We just put a string instead of an integer, and that breaks the program and puts us in a debug session. And since we're root, we can do something like import OS and just execute commands as if we were root. And thus, we can cat the root flag. Next, we have cron jobs. Cron jobs actually, I don't believe I explained it before. Cron jobs are essentially scheduled tasks. They run things every so often. Whatever is specified, at whatever time is specified by whoever owns that cron job. There are a couple of things you can do. If it's a bad cron job and it's doing something like running a bunch of scripts in a different directory, just through something like a wildcard, you might be able to put your own file there if you have the right permissions and execute a file as a different person. If, of course, you can modify the binary or the script that the cron job has specified, you could do the same thing there. To actually find these, the best way is probably pspy. It'll show you, again, processes running. And if you see something, you see something that keeps appearing every so often, you might be able to assume that there's some sort of cron job that's constantly running this binary, this script, etc. every so often. Next, we have kernel exploits, and these really just target the Linux kernel of the device you're attacking. I'm not too familiar with how a lot of them work, but there's stuff like dirty cow, pwnKit, etc. And to find these, one of the easiest ways to find this information is, again, through linpiece. It'll tell you the kernel version and whether or not it's vulnerable to some exploits. However, do be warned that, like I said before, linpiece isn't always that accurate, and it's really not that accurate whenever it comes to kernel exploits. For some reason, it pretty much always likes to tell you, hey, this thing is definitely vulnerable to something like dirty cow or pwnKit. It'll always highlight it in orange, telling you this is pretty much a guaranteed way to prevest to root. But on a lot of modern Linux boxes, it's generally not going to be vulnerable to those exploits, especially on something like Hack the Box. So it'll always bait you into doing it, but it's still a good idea to just try it whenever you're kind of stuck, since sometimes, hey, that's the answer. Next, we have path variable hijacking, and this takes a bit more explanation. So what the path variable is essentially a list of shortcuts. So if you've done stuff like type ls or ps, you might have noticed you only need to type only that part of the command in order for the binary to run. However, if you were to do something like which ps or which ls, it might tell you the entire path, something like user bin ps. The reason why you can do this is because of the path variable. Whatever is in your path variable gets searched to see if that binary exists, starting from the left to the right. So with the example of ps, first it'll check /user/local/sbin to see if there's a ps binary in there. If it isn't, it'll go to the next one, user local bin, and try to find a ps binary. If that fails, it'll continue over and over until either A finds it or B, it fails, and it will tell you command not found. What's important to know is that path always checks from the left to the right. So you might be able to abuse this, though this attack requires a bit more than just being able to modify your path variable. I actually have an example of how the path binary, or rather the path environment variable, how you might be able to abuse the path environment variable if given a binary with, say, SUID bit as root or a different user. So first, right here, you can see that we have two binaries, one called safe, one called vulnerable. And here I'll show you that they're both SUID bits, so they'll be running as root. So we're just going to do a strings on the binary, which just shows you whatever strings it can strip from that binary. And if you can see with this, the vulnerable one, which is at the very top, come on. If you can see with the vulnerable one at the very top, it is calling ping taxi directly, while at the very bottom, if I highlighted it, it's calling user bin ping. The vulnerable one is calling it through a relative path, while the safe one is calling it through a full path. So we might be able to abuse this. Again, path checks from left to right. So if we can change our path to be our current working directory, and we have a thing called ping in there, we might be able to hijack its execution flow and have it execute our malicious binary instead of the actual ping. And here is just showing you what the actual binary does. It just does a normal ping on whatever IP you set on it. Here I'm showing you that I've already created a malicious binary, just a malicious bash script called ping, and I'm now exporting the path to be our current working directory. I should have showed what the path variable actually looked like, but you can assume it's going to be the /ob/cptc yada 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 slash path hijacking, and then colon, and then the entire rest of whatever the path originally was. And now finally, if we run the same vulnerable binary, we can see that instead of running what it was expected, which is the actual ping binary, it runs our bash script and shows that we are now root. Here's the same example again, slightly modified, but in a text format. Again, the vulnerable one calls ping with a relative path. At the top, we create a binary called, or rather a bash script that's called ping, and make sure it is named the same thing as whatever the vulnerable binary calls it. Finally, we export our current path. We export our current working directory into our path. And here I actually show you that it's on the very left, meaning it'll search our current working directory first before anything else. And then finally, we run again the vulnerable binary, and hey, look, we're root again. Finally, we have environment variables. There are, okay, so with this, we have stuff like LD preload and LD library path. LD library path is, if you're familiar with Windows, essentially DLL hijacking. Or at least what I believe is just DLL hijacking. So it's similar to the last exploit where you want to name, at least from what I believe, you want to name the file the same name as a different library that a function calls, or that a binary calls, and instead of running the legitimate binary, it'll run yours and whatever function you specified in it. We're not going to be covering that one. Instead, we'll be covering LD preload. LD preload loads a shared object file before whatever binary you called gets ran. What a SO file is, at least from what I believe, is essentially, again, a DLL from like Windows. It's just a bunch of functions that things can share and use. However, SO's work isn't too important. What is important to know is that whatever is in the LD preload environment variable, whatever SO files in there, gets ran first before the binary actually runs. And SO files are just compiled C code. So if you are able to do something like, or rather, you can create your own SO file, something like what I've provided at the bottom. And there's a bit of a catch with this exploit. You can write it, you can create it, you can set your LD preload to the SO file, but you want to run this as a different user. So that would be something like an SUID bit or sudo. However, both of them by default don't keep this environment variable whenever you run the program, since it's a known attack vector. So for security reasons, they don't keep it normally. However, for something like sudo, if it's configured and in an improper way, say it keeps your environment variables when running the sudo command, then you might be able to abuse this exploit. Again, I have a bit of a quick demo here. I really should have zoomed that in. That's my bad. But yeah, what it's showing is you have the ability to run a binary PS, I believe, and you have the ability to set your environment variables when running. And so if you write your own malicious SO file, like the one I provided before, you compile it into an SO file. You can then run sudo while setting the LD preload or the LD preload environment variable. And once the binary runs, it'll run your SO file first, running whatever malicious code you've intended for it to run. And in this case, it runs as the root user, since there was nothing restricting our sudo access, so it's going to run it as root. Here, just do an ID, and at the very end, once I exit out of the shell, You can see it runs the rest of PS, and that's again because it runs the SO file before actually running PS. Or whatever binary that is specified. So yeah. There was quite a bit of stuff to cover, but I think it's more fun to do a hands-on lab. So here are the lab instructions. I probably should have posted here which one you should clone, but there is on Camino a template called CPTC, I think 24 week 4, something like that. It should be pretty obvious. And you're given a router, 2 Linux machines, and a Kali machine in it. Your goal is to find as many vulnerabilities as possible, though if you want to know how much you need to do for the homework, it's 3. Do make sure you take screenshots and know how you attacked it. Take screenshots of all your steps, since you will need it for the homework. Yeah. You'll be talking about how you exploited it, how it worked, along with, I guess I forgot to update this slide more, the impact of that vulnerability and potential ways of remediating it. If you want to know the full details, I'd recommend you go to the shortened link, since that has your homework document and it explains a bit more that I forgot to write on the slide. So yeah, that's pretty much it for this meeting. The rest is just going to be doing the lab, which is also your homework. So do try to get as far as you can and do ask for help. We're here to help if you have any questions. So yeah.